Space team is looking at the interfaces to the chamber. Jim White's working on the ground station. Jeff Brewer. Some wire harness work going on back here.
Hey, good choice.
Okay, this is the AMSAT and AMSAT MA being mounted. First one to be mounted to the thermal plate here this evening, first of 4.
The arrival of the software crew.
Yeah. The late night workers.
You're just leaving the antennas off and feeding into them.
Yes, sir.
Is there a problem, Jim?
You're going to shake. Shake. Well, see how I got small. We get no shake. Mike. What do they do? Shake? But we can move them out.
We need 18 more books.
7, it says. Oh, the number got peeled off.
This is the bottom, which is 26. Right?
This is 27.
But this is wrong. This would be the bottom of the battery case. I'm gonna check this. Because I said this battery case should be 27.
Oh,
We got one here broken off, should it be? You may fire when ready.
what are you doing to that one?
I'm just putting in a hex head bolt for the ground lug, for the power. Chassis ground.
Oh. Jim. What are we doing here, guys? We got I got two cables on the top of this space thread. I just love space game. Yeah. Did you lock your loop? You need to lock your loop and control law.
This is the AMSAT team. They're tightening down the last of the hardware. Got the cables pretty much attached. Dave's over there cleaning some of the cable, make sure it doesn't outgas. Have a few more connectors to put on. And but all 4 spacecraft are mounted on the plate. And won't be too long now.
And who would know?
They would know. Don't worry. They would know.
One would be.
We didn't even do that. This is what I had all of the spots.
What is the worst? What is the maximum RMS?
7.3.
No. Is the DCI spec? 7.2. No. That we will be
The Microsat ground stations. There's actually two stations here. PSK modems up top of the computer. Over here we've got the other one. It's about almost 10 after 1 in the morning, and the crew is still doing the final wiring on the spacecraft.
Hey, Harold, I bet every damn one of these low forks work. Maybe. Now we got.
That's Bob McGuire inside the chamber, and he's hooking up the cables on the inside of the chamber. You'll see him squeeze back in there. But he's a caver.
Well, the problem is then how to get it all the way in.
Are they long enough, Bob?
These cables here are not quite long enough.
Yes.
Pull the whole assembly in some more. We'll do that. Yeah, let them show. The clean can come on. Don't fork it too much. That problem is the point. If you get those right, yeah, I should just make it. Poke them out if they're long enough. Great, that'll be fine. Yeah. You would have this will go a lot faster. That way, I didn't know you could pull that. Well, we got some way of double checking that most of them are right. That'll make it harder to get the last one wrong.
Tear it up, it's paid for. It's like a lot of fun.
Well, somebody's got to do it. It's a dirty job, but somebody's got to.
I think it's unbelievable. It's like in the ship in a bottle how we got Bob in there.
We've got to take these guys wild.
How are we going to get him out? Forward or backwards?
We
Well, we gotta
take
wait
these
till
guys
after he's
wild
freeze-dried.
back.
We ain't going to get Bob out. We're going to have a freeze-dried Bob.
We're just going to drift and close the door and he'll get out.
Mummified Bob. I got it.
Okay, that's the microsats in the chamber. There's one of them there, one of them over in there. We're at deep vacuum, about 45 degrees C, and testing is continuing.
All four spacecraft are working.
All four are working. That's good.
Okay, you take a picture of the spectrum.
Beta. We got a live signal here.
This is a 70 centimeter transmitter from Weber State's Microsat.
AMSAT NA.
Oh, I'm sorry, yeah, we're on AMSAT NA, that's right, we changed it. And this is the main carrier here, and we're sending regular packet flags so that you can see the little lines on either side that caused by the packet flag sideband. So it's a good looking transmitter.
Good.
Test of the QPET's latest version of the bootloader on the development system. This is the first board that we had made and debugged by the people from LA and San Diego, and Harold Price has it writing all the main kernel and operating system for the satellite.
Okay, great. Black cables coming down and wrapped around that box are the 9913s for the external antennas. One of these antennas we have coming around here and connected to a W6OAL special power divider, and then that's dividing up the power and feeding the four spacecraft. And from that we can talk to the spacecraft with a single antenna. Not a whole lot to see from outside the chamber. Spacecraft were positioned in front of this chamber last night and slid into the chamber. And let's see here, this is the Big Bird chamber.
That's the 70 centimeter PSK transmitter. That's what you'll hear on the downlink from the three of the different microsats. This is AMSAT NA's straight PSK transmitter beacon on 437.025, plus or minus a little bit. It's kind of hot in there, so the frequency's shifted a little bit.
Okay. Are we going to attempt to try to get some good frequency data?
Yeah, we're trying to fix up the ground station software so command is more reliable.
Okay, will it be no carrier, or will we go after a average?
There's no way to shut the modulation off.
Oh, okay. Okay.
We want off IOU, right? Well, I can use any of IOU to do the trick. Probably I'll use that just as it does. Okay, good. It gets every one now. Okay, good. Okay, fine. Well, yeah, because we're going to have to not up off it. I think it's fine. Now see if you can blow away on your shaft.
Just got here.
Oh, good.
Okay, Dave is going to swing in and pick him up and bring him in here.
Okay.
Trying to eliminate some TNCs and go directly to a. There. That's more better. More sanitary.
Oh, there's less connectors that way. Another Booker T special there.
That was really lucky. So
Oh.
that's already, it's ready to go to the hem check. Yeah, we can have 4 positions if we want. And we have 2 dummy loads. We only want 2 stations up. We'll just load the power splitter with 2 dummy loads.
Okay. It's Friday evening, about 5 o'clock in the evening, and the team is reassembled to perform some testing at cold, and also to establish a remote command link with the ham station across the way. And we're rocking out, as you could tell.
It's got nothing to do with the power.
That's 30 millivolts right there.
Yeah, I don't even put more in that. So it's deviation rather than power.
There's not much you can do about that on a commercial transfer.
Well, we just gotta.
You can get in there and turn it down.
Hey, we're ham radio operators. That means we know how to take a knife to our
That's right.
equipment. Turn it all the way one way, all the way the other way.
That meant all you needed to know how to do is to get your credit card number over the phone so that they send you a ring.
Nah.
Those are users.
Ah, I see.
Builders know where the knife goes.
Especially on donated equipment.
Yeah. Well, especially for the.
What's chirping away?
Pardon?
What's that chirping away?
Oh, that's telemetry. We're asking it to send telemetry, and it is.
Oh, okay.
We're using that now to tune the input so we can determine what the right signal levels are.
Receiver. And tune it to 437 150 so that you can see it coming out. Oh, you want to keep there.
Transmitters out there.
I don't believe that.
Even cold?
I believe transceivers. Look, Chris, there's 2 kilohertz separation in the frequency those guys are reading out.
Right, you're right. Well, then again, but we may not be hearing exactly the same pitch either. Yeah, so we could.
Got it too loud, I think. A little higher. There you go.
Yeah, it's still not receiving.
You're on a false band, no doubt. They come back there.
Yeah, it's still not receiving.
I want the side lobes.
Yeah, I'm sure we are.
Yeah.
Had a DCD for a minute.
Well, we're not sure the correlation between a DCD and whether it's actually receiving. Too many side loads is the problem. Well, it's a learning thing. It's like anything else, once you've learned what it sounds like, then you'll have no problem tuning it in.
And look, believe me, it will be easier in space. You won't be able to hear all the side loads.
Yeah, we're hearing side loads all the way out.
Yeah, good point.
Okay.
Has stopped receiving stuff.
No, they're good.
Okay.
It's active.
Well, it did not. Interestingly enough, the last one it quit on was at NLH, which probably meant it heard on another receiver.
What? I'm trying to get a cable that'll fucking reach.
Oh. We were that much further away?
No, goddamn cables are all different.
Hey, they're the best I could scrounge.
Now, wait a minute. All you needed to do was take the one out
I'm
of...
just trying to do that.
Okay, in all aspects, this project is being conducted at the highest technical level. You can see all the equipment. Yes. What's that?
It's a finely tuned ground plate. He's got to dust it off now.
You said it worked everything.
Oh, well, yes.
Well, yes, well.
But it actually doesn't. We had two problems. Like this one. There we go, there we go. You leave your computer? Yeah. Right.
Yeah, I'll do it. How do you do the SC load age? You go ahead and do that, and then I'll...
No, you don't do the SC loading. Oh, you do.
Unload.
Here's the LU set telemetry. It's a mass spectrometer showing the outgassing characteristics. What?
What was yesterday? The date?
Friday, the 14th. Oh, Friday the 15th. Yeah. Did you just do another plot? You're going to do another plot?
I can if you want one.
Do we have one at this temperature? Do we have one at this temperature?
Yeah.
Okay. This is the control panel for the 5x10 chamber. And here's the test conductor, Rex. How's the temperatures look, Rex?
They seem to be holding pretty good.
What's the control at now?
Control's at 46.
Okay. And we'll trip if any of them get to plus 50?
That's it. 50 skills on all of them.
Okay. So we're scrolling through them there. 45.9, okay. The one's cooler. That must be the one we have turned off right now. Where you control the different phases of the tests and everything from there?
Yeah. The panel controls everything.
Yeah, that's neat.
That one's yours too over there.
Which one? Oh, over there?
Microsat control for small pressurized heat exchanger.
Oh, okay. Where's that witness plate temperature?
You can't. That's the L2 cold plate.
Oh, that's the cold plate. Okay. Is that when you have three? Oh, okay. I know what it is.
That's
Okay.
right. That's the contamination plate.
Yeah. Okay.
Amateur radio recreation.
Weird dynamics there.
You can get satellites into space, but I don't know about this one. All right. Whoa. Pretty good.
there. See it? The thing itself is huge. So much time. Solar panels probably cost getting quizzed on phase 4, which is something about which I know nothing.
Good Broadway. Of course, after 36 hours up, anything looks good. Jan looks good. Well, but that's pretty norm for the course.
Courtney's always looked ugly, but then that's the way he was born.
Well,
Colorful, the badge.
We had determined it didn't have a matching pair to it.
Who's flying around tonight?
the junior operator's here. Right there.
Home or outside?
Like 4 o'clock time frame? Yeah.
What, 4 in the afternoon?
Tourists.
Took off.
Don't know when to get out of the weather.
Clouds come over, get out of the weather, right? At least Jack didn't have to contend with that problem of putting the antennas on top of SSD this time.
And here's the Martin Ham Club. The tower and the HF antenna. All the vehicles around the ham shack. And we're up there with some of the antennas.
Jan King, maybe you better talk to Bob since you're out of the chamber now.
Okay.
Lock the wheels.
Climbing blocks for
Does it look okay, Jose? What do you think of the test?
I think the test went very well, given the amount of time we had to get ready for it going into it. All the spacecraft functioned reasonably well. We had a list of action items to work off on the problems we had in the test. Most of them having something to do with computers and the like. And we get that sorted out, it's pretty well ready to fly. It's very nice at how clean the spacecraft seemed to be. Also, the performance of the RF system seems to be quite good. And, we're going to have a good mission here. Everything is squared away.
We're going to make the launch?
You bet.
The Microsat spacecraft awaiting packing for shipment, installation of solar panel. All 4 spacecraft.
That's an educated eye. There's about 1 part per billion. What's 2 parts? Which part?
By the way, have you ever correlated parts per billion of anything to what you see on a witness plate, which is milligrams of stuff and so much solid? Or
I asked them to look into that and see if, how relative it was to other spacecraft, things like that.
any feedback?
Huh?
Did they just know from experience watching other hardware?
No, not really. They said it was more ammonia.
Yeah, that's for sure.
Okay.
Never saw ammonia before at all. I know exactly where that is.
Well, nothing clings like ammonia.
Well, it's not going to stick on anything, that's for sure.
No. Well, let's get these things out.
Before we do this, we want to pull it down.
Gotta cover that first.
Bravo.
Number 1.
Good task for the race. Yeah, that's yeah, exactly.
You want to go downstairs?
But I think it goes on the elevator.
Well, we'll send it down and then go down and meet it.
We got a couple of cars.
Well, 80% of what's in the elevator is in my car.
There must be a big car.
What could I be doing wrong?
You mean there isn't enough light?
No, it's still flashing.
Not a very good camera.
No. Really. It is a nice camera.
I mean, it looks pretty good in the viewfinder, but
Yeah, you can really see it.
yeah.
I can find my shoes.
Well, they're good.
Still no good. Yeah, I'm gonna go mobile for a second here.
No. Yeah, that's right there. Too true.
No hurry, it'll be 2%.
Hey, there's actually enough light for a change.
Really?
Amazing.
Let's do it.
Hurry, hurry.
Sir.
I'm recording, I'm recording.
Okay, I'm gonna give Jim the high sign.
Okay, ready?
What's he doing?
Is everybody, he's in my car.
Is everybody ready?
Got the current limit. Have you got the current limit all the way turned up, Jeff?
Okay.
No.
It's all the way up?
Should be rotated all the way clockwise.
Clockwise.
Move.
5, 4, 3, 2, 1.
Oh, gee!
Did you like it? Did you
Yeah,
like it?
that was good! That was great!
For these foods. And we'll sequentially do these and I think probably successfully operate these.
Okay, what kind of antennas do we need at the camp shack? Want beams to go over through the hog back to get to the top? Want omnis?
If, you know, I think you could probably do it without, we got the same sort of station.
The shipping container. Solar panel.
It was have them in some kind of a case we could take down there. They could set on a table in a rack, you know, sort of a thing.
Yeah, seriously. Probably a good idea.
Screw terminal thing, screw lock. And they couldn't get in the cabinet where it is because it was during the mission. And they're secure during the mission.
Right.
Okay. I know, it's dangerous, and it scares me too.
Because you could get down there with all that equipment.
Being a disaster, I know. And that they couldn't stand it.
Well, that was because of the
That's about 19 inches right there.
the long one.
That much.
The wrong
Oh,
the wrong dimension one
This
won't.
one, yeah, no way. Yeah, that's why I got on the net, because I thought that dimension has crept into everything.
Yeah.
Yeah. And then something either in Doug's QST article or in the AMSAT journal article, it talks about a rod antenna on 2 meters.
Yeah, well, what we're thinking of there is a disc. It's a kind of a cute antenna, because it solves all your problems at one time. It's going to do that. Okay. This comes down to the top of the spacecraft like this. And you gamma match this, 2 meters. And that's like the sleeve of a piece of coax, semi-rigid, although you might have to stiffen it by putting it inside a piece of fiberglass or something. So it's got a fiberglass wrapping. And then up here, you got a disc cone. So here's the disc, and that's the center element. And then this piece of coax is fed here to the S-band transmitter. We even had thought about, since a disc cone's a broadband antenna, if we got an L-band receiver done in time, so we had a mode S, really, you know, piece of equipment, we could put a diplexer here and put the L receiver on that thing too, and the disc cone would be working at both frequencies. So we could get SL and VHF all in the same piece of stuff. And because this is so fat here, this end, it end loads the 2 meters, and you can actually get the electrical link
Short.
a quarter wave.
Yeah.
So it's really a cute little.
This is a true front of the envelope designing.
Yeah. Well, that's as far as it got too.
Similar to the little wheel, similar to the mini wheel, and now we have micro wheels.
Okay, and what's that cut for?
This is cut for 2,400.
Okay, the S-band. And which spacecraft is that?
This is Dove.
That's Dove, okay.
And it doesn't matter which one we fly it on. talked with Jan yesterday. He thought we might fly one type of antenna on the Dove and one type of S-band antenna or another type of S-band antenna on the other spacecraft. So we have live filers, and by the time everyone gets to Peru, there will be 2 of these in case one of them gets broken, mutilated, whatever. They seem to be going through Vive very nicely. Thus far, they hasn't come apart. Probably random Vive will tell the story.
Okay, and we'll see that in a few minutes.
Yes.
What spacecraft is that on the shaker head now? LUSAT, okay. And we're shaking that without the antennas?
Yes.
Okay. Okay. Do you know if we fired up AMSAT NA yet?
I do not know.
Okay.
We've tried to get Jan all day and haven't been able to reach him.
Okay. Again, that's
AMSAT LU.
oh, LUSAT, okay. And it looks like it's mounted on the shaker head, ready for Z-axis.
Random Z.
Okay, random vibration, Z-axis. The close-up of W6OAL's micro wheel.
Horizontally polarized should give a vertical pattern or something similar to vertical. That all spots that the footprint sees under.
Okay, here's another picture of the micro wheel mounted on top of the Dove spacecraft.
Z vibration. Or Z random vibration.
Okay. This is LUSAT, Z vibration, random. Something's making some noise. Okay, this is Dove, Z-axis, random vibration. Well, shut down. this is Dove, Z-axis, random vibration. Minus 12. A little bit of rattle. Shut down. Okay, the test was aborted because of a high frequency vibration that was being picked up upstairs. The team has elected to go ahead and run minus 12 dB again, and by dampening the oscillation of the antenna and the separation spring, we'll see if it's that. If so, then we'll continue up to normal speed. Okay, we're restarting the test. Minus 20 dB. That's it. It's a spring. Did that antenna break?
Yeah, right there. Capacitive. Copper.
Oh, the little copper.
They're all your bugs. Yeah. These are oscillating. That's
And that's Microsat being mounted on the vibration table. The failure analysis is well underway.
You know where. You know how to fix it. The storing and the setting it up at the exact time and a weak point to confirm that. Also, some damping can be done on the elements in between two elements. So this moving rapidly. You can see much more go down.
Microsat, Z-axis. Did we abort?
Yeah, they boarded.
Okay, we've raised the analog aborts. The springs was making too much noise and aborted the test. We've raised those limits and we're going to rerun the test here in just a moment. Okay, we're at minus 20 dB. Minus 12. Jim is inserting a pen to verify that it is a spring that's making the high frequency noise. And yes, it is. Test complete.